For more than a decade, America believed Tesla had already solved the electric vehicle problem. Not because every Tesla was perfect, not because every EV driver loved planning around battery percentages, but because Tesla built the one thing Detroit did not control: charging confidence. The Supercharger network became the psychological bridge between gasoline America and electric America. But now BYD is attacking that bridge from a different direction. The BYD Han LEV is not important here because it is a sedan. It is important because it carries a claim that should make every EV strategist in America stop and recalculate 1 megawatt charging 1,000 volts, 1,000 amps, and up to 400 kilometers of range in 5 minutes. This is not a car review. This is not a horsepower story. This is not another Chinese EV trying to look futuristic. This is an attempt to erase the last emotional advantage of gasoline, the feeling that refueling is fast, simple, and impossible for EVs to match. If BYD is right, the next EV war will not be won by the biggest battery. It may be won by the company that makes waiting disappear. To understand why BYD's 1 megawatt charging claim matters, you have to understand what Tesla really won in America. It was not just the EV market. It was not just software acceleration or minimalist interiors. Tesla won something deeper. It made millions of Americans believe that an electric vehicle could leave the city and survive the highway. That sounds simple now, but it was not simple when EVs were still seen as fragile urban machines. For decades, the American driver was trained by gasoline infrastructure. If you drove a Ford F-150 across Texas, a Chevrolet Silverado through the Midwest, or a Ram 1500 into the mountains of Colorado, you did not think like an energy planner. You looked for a gas station, filled up in a few minutes, and kept moving. Early EVers broke that rhythm. They forced drivers to ask uncomfortable questions. Where is the charger? Is it working? How long will it take? What happens if it is cold? What happens if the battery's low and the next station is too far away? Range anxiety was never only about miles. It was about control. Gasoline made drivers feel in control. EVs made them calculate. Tesla understood this before Detroit did. Detroit knew how to build vehicles Americans trusted. It understood steel torque towing assembly plants, dealer networks, and loyalty built over generations. But Tesla understood that an EV could not win as a product alone. It had to win as a system. The car, the charger, the navigation, the payment, the route planning. All of it had to feel like one machine. That is why the Supercharger network became more than infrastructure. It became a moat. It told the American buyer, you may not trust every EV, but you can trust this ecosystem. For a long time, that was enough. Other automakers chased range. They announced battery sizes, horsepower numbers, and electric trucks with enormous packs. But Tesla owned the most important emotional asset: confidence on the road. Then the industry made a dangerous assumption. It began to treat charging reliability as the final battlefield. If everyone could access better chargers, the problem would slowly disappear. Detroit moved toward Tesla's charging standard. Rivals accepted the logic of Tesla's network. The market started acting as if the EV charging war had become a network access problem. BYD is challenging that assumption. It is not merely asking whether chargers are available. It is asking whether the definition of fast is about to change. If Tesla made 20 or 30 minutes feel acceptable, BYD is trying to make 5 minutes feel possible. And once that idea enters the market, every existing benchmark begins to look slower. That is where the BYD Han LEV becomes important, not as a luxury sedan, not as a style statement, but as physical evidence that a laboratory claim is being pushed into a production car argument. The Han L turns megawatt charging from a theoretical headline into a visible industrial weapon. Tesla taught America to trust charging. BYD is now asking whether that trust is fast enough. The first thing Americans need to understand is that charging speed is not magic. It is physics. At the simplest level, Electrical power is voltage multiplied by current. If you want to push more energy into a battery in less time, you either raise the voltage, raise the current, or do both. But the higher the current gets, the more heat becomes a monster, hiding inside the cables. That is why voltage matters. A 400-volt EV architecture was once acceptable because the early EV market was still learning how to scale. Then 800-volt systems became the premium benchmark, because higher voltage allows the vehicle to move large amounts of energy with less current for the same power level. Think of it like expanding a highway. If the road is wider, traffic can move faster without forcing every lane into chaos. BYD is now pushing that argument into the 1000-volt zone. Its Super E platform is presented as a full domain 1000-volt architecture, not just a charger trick. BYD says the battery motor power supply, air conditioning, and other major systems are brought into the kilovolt class. That matters because 1 megawatt charging is not just about a powerful plug. The whole vehicle has to be designed as a high-voltage organism. For a driver crossing Texas, this changes the question. It is no longer only how far can the car go. It becomes how quickly can the car recover after the battery is drained. That is a brutal shift because range can be advertised on a window sticker, but recovery time is what a driver feels when he's standing at a charger with miles still ahead. But voltage is only one side of the weapon. BYD's claim also includes 1,000 amps of charging current. That number should not be treated casually. 1,000 amps is an extreme electrical event for a passenger vehicle. At that level, heat is no longer background noise. Heat becomes the battlefield. This is where many charging headlines become misleading. A company can advertise a peak charging number, but the real test is how long the car can hold that power before the system pulls back to protect itself. Batteries hate uncontrolled heat. Cables hate uncontrolled heat. Connectors, inverters, cooling loops, and power electronics all become part of the same stress chain. BYD's answer is not just to raise the number. It says its flash charging battery creates ultra-fast ion channels. From the positive to the negative electrode cuts, internal resistance reaches 1,000 amperes and supports a 10 coulomb charging rate. If that system works reliably, then BYD is not simply forcing more electricity through the pack. It is trying to redesign the path that electricity takes once it enters the battery. Now place that in an American road scenario. A family leaves Los Angeles for Phoenix in summer heat. The battery is already warm from highway driving. The outside temperature is punishing. The charging station is busy. At that moment, 1 megawatt charging is no longer a launch event claim. It becomes a thermal endurance test. Can the charger, the cable, the pack, and the cooling system repeat the performance without turning the stop into a managed slowdown? That is why this technology matters beyond the headline. At 1 megawatt, the engineering challenge is not just speed. It is repeatable speed under abuse. The most dangerous misunderstanding in EV charging is assuming that a powerful charger automatically means a fast-charging car. It does not. The charger can offer the energy, but the battery must be able to accept it. If the pack cannot absorb that power safely, the number on the charger becomes theater. This is where the old American EV strategy starts to look incomplete. For trucks and large SUVs, the instinct has often been simple. Build a bigger battery. More kilowatt hours means more range. More range means less anxiety. That logic works to a point. But a huge battery can also become a huge burden if charging it takes too long. Imagine a Ford F-150, lightning towing in Colorado. The truck may start the trip with confidence, but towing changes everything. Aerodynamic drag rises, energy consumption climbs. Range disappears faster than the brochure promised. Now the owner does not just need a large battery. He needs to recover useful miles quickly enough that the trip still feels like a truck trip, not an energy management exercise. BYD's Han L enters the story because it represents a different philosophy. The battery is not just a storage tank. It is a high-speed intake system. It must accept energy with the violence of a fire hose, while remaining controlled enough to preserve safety, durability, and performance. That is a much harder engineering problem than simply adding more capacity. If this philosophy scales, it attacks a core assumption in the American EV market. The next battery war may not be about who carries the most energy. It may be about who can take energy back the fastest without destroying the pack. But there is a reason this story cannot be told as a simple victory lap for BYD. A 1 megawatt car needs a 1 megawatt world around it. That means chargers, cables, cooling systems, power cabinets, transformers, grid connections, permits, land software, and probably energy storage buffers. The visible charger is only the tip of the industrial spear. This is why Tesla remains dangerous. Tesla's strength has never been only peak power. Its strength is the network, the site planning, the software, the reliability, the payment experience, and the ability to make charging feel predictable. Tesla's V4 Supercharger post lists up to 500 kilowatts for passenger vehicles and 1.2 megawatts for semi. But Tesla's deeper advantage is that it has spent years learning how charging behaves in the real world. BYD's challenge is different. It must prove not only that the Han L can accept extreme power, but that megawatt charging can become a repeatable system. In China, where infrastructure can be built with speed and coordination, BYD may gain an enormous learning advantage. Every station becomes a data point. Every failure becomes a lesson. Every improvement lowers the cost curve. For America, this is the uncomfortable part. Deploying 1 megawatt charging across rural highways, truck corridors, Midwest winter states, and suburban commuter routes will not be easy. The US grid is fragmented. Permitting is slow. Utility upgrades are expensive. But if China learns megawatt charging at scale first, the gap will not only be in cars, it will be in operational knowledge. The charger is only the visible weapon. The real war is behind it: transformers, cables, batteries, cooling loops, permits, and grid capacity. To measure the threat correctly, do not compare the BYD Han LEV as if it were just another sedan fighting for attention. That would miss the point. The Han L is not dangerous because it might outsell America's trucks tomorrow. It is dangerous because it carries a new charging expectation into the market. And once expectations change, every familiar benchmark begins to look different. Start with Tesla Model Y. In the American EV world, Model Y is not just a successful vehicle. It is the face of mainstream EV adoption. But its strongest weapon has always been bigger than the vehicle itself. Tesla sold the car and the road together. The Supercharger network told buyers that an EV could be practical, predictable, and road trip capable. That is why Tesla's moat was never only battery range. It was charging trust. BYD's 1 megawatt claim does not erase that trust overnight. Tesla still has coverage, software integration, reliability data, and years of real-world charging behavior. But BYD attacks Tesla at a more psychological level. It asks a brutal question: if Tesla made charging acceptable, what happens when another company tries to make charging feel almost invisible? Now look at the Ford F-150 Lightning. This truck carries one of the most important names in American vehicle history. F-150 is not just transportation. It is work, identity, loyalty, and proof that Detroit understands American utility better than anyone. But electric trucks expose a different weakness. When towing energy consumption rises sharply, range falls quickly. And when that happens, charging downtime becomes more than an inconvenience. It becomes a threat to the truck's mission. Imagine towing through Colorado. A gasoline F-150 loses efficiency too. But recovery is simple: pull into a station, refill, and leave. With an EV truck, the owner is not just asking how far it can tow. He is asking how long it takes to become useful again after the battery has been punished. That is where BYD's charging philosophy becomes disruptive. Even though the Han L is not a pickup, it changes the standard by which pickup charging will be judged. The Chevrolet Silverado EV faces a similar pressure. GM can build large vehicles. GM understands scale. And Silverado EV uses the logic many Americans understand. A big vehicle needs a big battery. But a huge pack can become a double-edged sword. It may provide range, but if charging still feels slow, the driver experiences the battery not as freedom, but as mass that must be refilled. Ram 1500 REV brings another kind of challenge. Ram buyers often value familiarity, road presence, towing confidence, and long-distance comfort. They are not easily moved by futuristic promises. For them, the question is brutally practical. Does this new system make my life easier, or does it ask me to compromise? If megawatt charging becomes normal somewhere else, first that question becomes harder for legacy brands to answer. This is why the American comparison must be framed carefully. BYD does not need Han-L to replace the F-15, Silverado, Ram, or Model Y immediately. It only needs to move the charging conversation. On a Texas highway, drivers do not want every stop to become a meal break. In a Michigan winter, they do not want cold weather to turn charging into uncertainty. In California, daily commuters do not want to plan their lives around plugs. The company that reduces waiting does not merely improve convenience. It rewrites the emotional contract of EV ownership. That is the real benchmark. Not sedan versus truck. Not China versus America in a simple scoreboard. The real benchmark is whether America's EV strategy can survive a world where fast charging no longer means acceptable delay, but near gasoline recovery. BYD does not need to win every category. It only needs to change what Americans expect from charging. If BYD's 1 megawatt charging system were only a laboratory stunt, Detroit could afford to ignore it. Automakers see spectacular prototypes every year. Most of them never become an industrial threat. But the danger here is different. BYD is not simply showing a faster charger. It is trying to build a new expectation around the entire EV ownership experience. That expectation creates pressure across the supply chain. Megawatt charging does not depend on one component. It requires high-voltage battery architecture, silicon carbide power, electronics thermal management systems, liquid-cooled cables, charger cabinets, transformers, grid connections, and software that can manage extreme energy flow without turning the vehicle into a reliability gamble. This is no longer just automotive manufacturing. It is vehicle engineering fused with energy infrastructure. That is where the geopolitical pressure begins. The United States can raise tariffs on Chinese EVs. It can restrict imports. It can protect domestic factories from direct price shocks. But tariffs cannot automatically stop an engineering learning curve. If BYD deploys megawatt charging at scale in China first, it gains something more valuable than a headline. It gains operational data. It learns where cables fail, where stations overheat, how batteries age, how drivers behave, and how utilities respond under peak demand. For American investors, this changes the question. The market should not only ask which company can sell more EVs next quarter, it should ask which company is learning the fastest across the full energy stack. Tesla understood this early. That is why its charging network became part of its valuation story. If BYD begins building a comparable learning machine around ultra-fast charging, then investors will start comparing not only cars, but systems. For union labor, the threat is even more complicated. The old automotive economy was built around engines, transmissions, exhaust systems, fuel delivery, and mechanical complexity. The new EV economy shifts value toward battery cells, high-voltage wiring software, power chips, thermal systems, and charging infrastructure. If Detroit is forced to chase 1,000 volts and megawatt-class charging, the question is not simply whether American workers will build the vehicles. The question is whether the most valuable parts of the vehicle will be built inside the American industrial base. This is why BYD's 1 megawatt claim should not be treated as an isolated technology story. It is a warning about industrial timing. If America waits until consumers demand 5-minute EV charging, it will already be late. The companies that define the standard first usually control the suppliers. The cost curve the testing data and the public narrative. So the real question is not whether tariffs can slow Chinese cars at the border. The real question is whether America can accelerate its own engineering response before the global definition of fast charging is rewritten somewhere else. The BYD Han L EV is not the center of the story because it is beautiful, fast, or new. It matters because it carries a message the American auto industry cannot ignore. If charging begins to feel like refueling, the entire EV debate changes. Tesla still has one of the strongest charging ecosystems in the world. Detroit still has scale factories pick up loyalty and generations of engineering knowledge. None of that disappears because BYD announces a megawatt charger. But industrial power does not collapse in one moment. It shifts when expectations move faster than incumbents can respond. If 400 volts was once enough and 800 volts became the premium benchmark, then 1,000 volts and 1 megawatt are now asking. The next brutal question is America leading the EV transition or defending yesterday's advantage? The danger is not that BYD has built a faster charger. The danger is that it may have changed what the world expects charging to be.